Okay, so moving into special right triangles, again, this unit deals solely with right triangles. So we're going to look at the reason they're special is because we have very specific angle measures. So we're going to look at 45, 45, 90 and 30, 60, 90 triangles. They have a different relationship with the ratios and their sides than most other triangles do. Keep in mind we're going to use what you did in class today with the radical reductions, and we will put no decimals in our answers. Okay, so quick review. We have two legs and a hypotenuse, so we can find a missing side by taking our leg length squared, so we'll call that leg 1, plus the second leg squared is equal to the hypotenuse squared. Because this is isosceles, we know those base angles are the same. So this is a 45, 45, 90 triangle. And because this is 5, we know that this is also 5. So we can plug those in. So we get 5 squared plus 5 squared is equal to x squared. So 25 plus 25 equals x squared. Combine like terms. And then square root both sides. Well, the largest square root that goes into 50 is 25. The square root of 25 is 5 with a remainder of 2. So 5 root 2. So if you look at these sides, this is 5, this is 5, this is 5 root 2. So you can kind of see there those relationships. Okay. Well, that relationship is consistent with every 45, 45, 90 triangle. So if we solved this one out real quick, you would get 3 squared plus 3 squared is equal to x squared. So 9 plus 9 equals x squared. Take the square root of both sides. This is 9 times 2. Square root of 9 is 3 root 2. So 3 root 2. So every time we have a 45, 45, 90 triangle, okay, what do you notice about the length of the legs and the length of the hypotenuse? Okay, the relationship between the legs and the hypotenuse in these isosceles right triangles, which is a 45, 45, 90 triangle. Every right isosceles triangle is a 45, 45, 90 triangle. All right, is that the hypotenuse is equal to 2 times, or is equal to the leg length times the square root of 2. Okay, so it's always 45 degrees, 45 degrees, and 90. Okay, so another example, those don't look exactly even. All right, anytime you see that as an isosceles, say this is 3. We did 3 already. Let's do 7, 7. So this automatically would be 7 root 2. You don't have to do the Pythagorean theorem if you see that relationship. Now, as you can see up here, doing the Pythagorean theorem will get you the same answer. Okay, the reason we know they're both 45 is that 45 plus 45 is equal to 90, and 90 plus 90 will equal 100. We know they're both the same because of the base angle theorem. So because it's isosceles, we know that they're both the same. Okay, so just labeling this here, we have, again, your leg. We have a leg. This side, always across from your right angle, is your hypotenuse. The ratio would be leg, leg, hypotenuse would be 1 to 1 to square root of 2. All right, so another example would be if this leg is 9 and this leg is 9, then this would be 9 root 2. If one leg is x, then the other leg is x, and the hypotenuse is x root 2. Okay. All right. So using that to find missing side lengths, if we see this is 45, again, if this is hypotenuse, or if this is isosceles, excuse me, this would be 45, and this is 45. So if we see that one is 45 by our base angle theorem, this is automatically 45. All right. So we know that x and y are the same. So here, if x equals 5, then y is equal to 5, and z would automatically equal 5 square root 2. All right, because these are your legs, so they have to be even, and this is your hypotenuse. So it's times the square root of 2. All right, so with b, same thing. We have y equals 6. This is a leg. So it's equal to the other leg, which is x. So x is also 6. And z is your hypotenuse. So it's the leg length times the square root of 2. Okay, this one's a little bit different here. If you look at C, we're given the hypotenuse, all right, which is z, which is 4 times the square root of 2. Okay, so remember in your hypotenuse, it's the leg length times the square root of 2. So this 4 represents the leg length. So that means that x is 4 and y is 4 because they are both legs. Okay. So what happens then on this next one if our leg is 3 square root 2? All right. Well, we still know that y is a leg, and so it is also 3 square root 2. All right. And our hypotenuse is our leg length times the square root of 2. So we would take 3 square root 2, our leg length, multiply it by the square root 2. This simplifies. When we have square root times square root, we can go underneath. So we have 3 times the square root of 4. The square root of 4 is 2, so we have 3 times 2, which is then 6. So the hypotenuse is equal to 6, and your hypotenuse is z. Okay, and last one, it gives you the hypotenuse z equals 8. Okay. Well, to get from having your hypotenuse to having a leg, we have to work backwards. All right, up here, the leg length could be seen right in front of that square root 2. Here we don't see that square root 2, which means it was something like this where it canceled out. So we're essentially moving from here up so that we can get that leg length. Okay, so to do that, the leg is the hypotenuse divided by the square root of 2. So we're going to take 8 divided by square root 2, which is our leg length, but because we have a square root in the bottom, we're going to do what's called rationalizing. We're going to multiply that by square root 2, and what I do to the bottom, I also must do to the top. So we have 8 square root 2 over square root 2 times square root 2. All right, so 8 root 2 over square root 4, which is 8 root 2 over 2. Square root of 4 is 2. And 8 divided by 2 is 4 square root 2. So this is your leg length. And so x equals 4 root 2. So also y is 4 root 2. Okay, so these three you're going to try on your own. Identify if you're given the leg or a hypotenuse, and then solve for the other ones. 3 is going to be just like E. So see that example for number 3. Okay, and then we have a 30, 60, 90 triangle, and we're going to look again at Pythagorean theorem. We still have, you have your leg, and you have your leg. This time it's very clear which one's shorter, so we have our short leg, and we have a longer leg, and we have our hypotenuse. So notice the longer leg is across from the 60, and the shorter leg is then across from the 30. That's true for any kind of triangle as far as lengths go. So if you have two sides, you can just use Pythagorean theorem. If you're given an angle, though, you can use your ratios. So the ratio of short leg to long leg to hypotenuse for a 30, 60, 90 triangle, okay, this is only for this type of triangle, is 1 square root of 3 and then 2. Okay, like for example, if your short leg was 7, all right, so this would be 30. If your short leg was 7, you would have the ratio 7 to 7 root 3 to 14. All right, if we call the short leg is just x, then we would have x times root 3 to 2x. And so those proportions in that ratio is always there, no matter what the triangle is. Okay, so if we're looking at this one, this first one gives us a is equal to 4. Well, 4 is your short leg. So we can just fill in our ratio. We have 4 as the short leg, 4 times the square root of 3, and then 4 times 2, which is 8, for the hypotenuse. All right, so leg, leg, hypotenuse. All right, so the long leg is the short leg times the square root of 3. Your hypotenuse is your short leg times 2. Okay. And you can label your triangle so you know where everything is. So second one, a equals 8. We're using the same triangle every time here, so again that's our short leg. So our long leg, we're going to take that 8 and multiply it by the square root of 3. And then our hypotenuse takes 4 times, or 8 times the 2. We double it and get 16. Okay, so what that says is if this is 8, then this would be 8 root 3, and this will be 16. Every single time it has that original proportion that you can use. All right, so what if we're given the hypotenuse? So in this case, the hypotenuse is 10. Well, remember, the hypotenuse is 2 times the short leg. So if we take half of the hypotenuse, we get the length of the short leg. And then the long leg is the short leg times the square root of 3. All right. So you can work from any side that you're given. So in this case, if your hypotenuse, or C, is 8, your short leg is 4. Good. And then your long leg is 4 root 3. Okay. E, they give you B. B is, in this case, our long leg. So our long leg is 6 root 3. Okay. Our short leg is equal to our long leg divided by square root of 3. Well, square root of 3 divided by square root of 3, our short leg is just that 6 in the front. Short leg times root 3, so that makes sense. And then our hypotenuse is always double that, so 12. Okay. Last one, again with the long leg. So doing that one more time, it's 10 root 3. All right, so we go to our short leg. It's always easiest to go from whatever you're given to your short leg, because both the long leg and the hypotenuse have a relationship with that. Your short leg is divided by root 3, so your short leg is just 10. And then your hypotenuse is double that, so in this particular case, it's 20. Okay, I know the video is getting a little long, but just want to do a couple more here in case you get some weird things. So again, we have our hypotenuse, we have our long leg across from the 60, our short leg across from the 30. So make sure you know which one's which. In this case, we're given the hypotenuse, so the hypotenuse is 2 root 3. Okay, well, the short leg is the hypotenuse divided by 2. So for this particular example, the short leg is 2 root 3 divided by 2, which is just root 3. And then the long leg is the short leg times the square root of 3. So we have square root of 3 times square root of 3, square root of 9, which is 3. Okay, so again, paying attention to what you're given so you know those relationships between those legs. Okay, hypotenuse is double the short leg. Okay, then if you're given B, then you're given the long leg. So here we have the long leg is equal to 9. Well, the long leg is square root 3 times the short leg, so I need to divide by square root 3 on both sides. So I take 9 divided by the square root of 3, which means I need to multiply by square root of 3 on top and bottom. So this is 9 root 3 over, in case you haven't noticed that pattern when we multiply a square root times itself, it's just that root number. This would be the square root of 9, which is 3. 9 divided by 3 reduces, and that's 3 root 3. That would be your short leg. Your hypotenuse is just double that. So 2 times 3 root 3. When we're multiplying with radicals, we just do outside times outside, so this is 6 root 3. Right. One more time for good measure. Here our long leg is 21. So to get our short leg, we're going to do 21 divided by square root of 3. So I'm going to rationalize that. So I have 21 root 3 over 3, which would then be 7 root 3. Hypotenuse doubles that. So 14 root 3. Okay. I guess I can go ahead and do one more example of B. The long leg is 4. So the short leg is 4 over root 3. Rationalize that one more time. So we have 4 root 3 over 3. That doesn't reduce, so that's our short leg. Okay. Our hypotenuse is double that. You do not double everything. When we multiply 4 root 3 over 3 times 2, it's like a 2 over 1. You just don't really need that. So that's 8 root 3 over 3. Go ahead and try those 30, 60, 90 ones. And that is that for that lesson.